A geometric sequence is formed by multiplying each term after your first term by a constant. So now instead of a common difference, we have a common ratio. And the common ratio is represented by R, and it's the ratio of any term by the preceding term. So if we want to determine if a sequence is geometric, we want to see if it's always multiplied by the same ratio. So we take our second term, divide it by our first term. And you should get 20 divided by 2, and by 20, I mean 10. And you get 5. Then we try it again. 50 divided by 10 is 5. 250 divided by 50 is 5. And 1250 divided by 250 is 5. So the common ratio for this is 5. Each step you multiply by 5 to get to the next step. So creating a geometric sequence. So we want to create a sequence which sixth term is 27. So what we're going to do is we're going to decide on a factor of 27. So one of the factors of 27 is 3. So let's let R equal 3. So to get our fifth term, we'll take our sixth term, divide it by R, and that will equal your fifth term. To get our fourth term, let me write this properly. T of 5, T of 4 will be your fifth term, divided by your ratio, which is 3. T of 3 is your fourth term, divided by your ratio, which is 1. T2 is your third term divided by your ratio, and that's supposed to be a 1. Oh my goodness. So 1/3, and T1 will be 1/3 divided by 3, which is 1/9. So your sequence would be 9, 3, 1, oops, except it should go the other way. 9, oh my gosh, I am just having problems. Okay, 1/9, 1/3, 1, 3, 9, 27. So here's your geometric sequence when R equals 3 with a sixth term of 27. The general term for a geometric sequence is Tn is equal to T1 R to the power of n minus 1. Tn is your nth term, so the term you're looking for. T1 is your first term, R is your common ratio, and n is your number of terms. So for the following sequence, 2, -6, 18, -54, determine that 10th term. So we want to find Tn to be T10. And n will be equal to 10. We're looking for 10 terms. To find your R, you take the ratio of your second term, divide it by the first, so -3, and T1 is equal to 2. Now we just plug it into the equation, so T10 is equal to 2 times your R, which is -3, to the power of n minus 1, which is 9. So T10 is equal to 2 times -3 to the power of 9. If you multiply this out, you should get -39,366. For the next example, we know that T1 is equal to 7 and T5 is equal to 567. We want to find T2 and T6. So what we're missing is our R. So we need to solve for R. So we know that T5 is equal to T1 times R to the 5 minus 1. And T5 is equal to 567. T1 is equal to 7 to the R times 5 minus 1, which is 4. I don't need to write that again. Oops. So now what we're going to do is solve for R. So we're going to divide by 7, and on the left side we get 81, and on the right side we get R to the 4. Now we're going to take the fourth root of both sides. Remember, on your calculator, you type, if you have a Sharp calculator, for second function yx, and that should get you the fourth root. And because our exponent is positive, r has to equal positive or negative 2. So the fourth root of 3 is 3, but it's positive and negative. So now when we solve for T2 and T6, we have two options. So when r equals negative 3, T2 is going to equal 7 times negative 3, because we know term 1 is 7, and our r is negative 3, so negative 21. And T6, just kidding, is going to equal 7 times negative 3 to the power of 6 minus 1. 6 minus 1 is 5. Negative 3 to the power of 5 times 7 is negative 1,701. So when r is equal to negative 3, those are your answers. When r is equal to positive 3, T2 will equal 7 times positive 3, which is 21. And T6 will equal 7 times 3 to the power of 5, which will be positive 1,701. So there's two options for your terms, one with the positive, one with the negative. So for the same question, the last term in the sequence is 45,927. How many terms are in the sequence? So we know that Tn is equal to 45,927. We don't know n. T1 is 7 from the last question, and our d we found to be 3. Let's just do it with positive 3. So what we're going to do now is we're going to solve for n. So we plug it into our equation. So 45,927 is equal to 7 times 3 to the n minus 1. Now we're going to isolate the side with our n in the exponent, so we're going to divide both sides by 7. So 6561 is equal to 3n minus 1. Now, because we're solving for a variable in the exponent, what we're going to want to do is make this side, so 6561, we want it to have a base of 3 with an exponent to something. So to do that, we're going to take 6561 and divide it by 3 until you get to 1, and count how many times you divided it by 3. So you type into your calculator, 6561 divided by 3, once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. And when you get to 1 on your calculator, that means you're done. So if you could divide 8 times, you know that this is 3 to the power of 8. And to test that, type in 3yx8, and you should get 6561. So now we have, let's get these out of the way, 3 to the power of 8 is equal to 3 to the power of n minus 1. Now that our bases are the same, we can cancel them out and just solve for our exponents. So 8 is equal to n minus 1. Add 1s to both sides, so n is equal to 9. To test this, you can put this back into the equation. So t to the 9 is equal to 7 times 3 to the 9 minus 1. So 7 times 3 to the power of 8. So 7 times 3yx8, and you get 45,927. Statistics Canada estimates the population growth of Canadian cities, provinces, and territories. The population of Nunavut is expected to grow annually by 0.8%. In 2009, its population was about 30,000. Estimate the population in each year to the near 1,000. So we want to find TN of T 2013. So we know N, we're going from 2009 to 2013, so that's 5 years. It starts at 30,000, and our difference is going to be 1.008. Now the reason for that is because 0.8% as a decimal will be 0.08, and because we want to include the initial population plus the 0.008, we add a 1. So that's our difference. Oops. Just kidding. That was supposed to be an eraser. So now we're going to plug it into our equation. So T of 2013 is equal to 30,000 times 1.008 to the power of 5 minus 1. So what you should get when you type this into your calculator is 30,971.58 people. And to round up, approximately that's 31,000 people. So the population in 2013 will have grown by about 1,000 people. Now we want to find it for 2049. So T of 2049. To find N, you take 49 minus 40, or 9, which is 41. So now we plug it into our equation. T0 for 2049 is equal to 30,000 times 1.008 to the power of 41 minus 1. And if you type it into your calculator, you should get 41261.265. So approximately 41,000 people in the year 2049, based on statistics.